Find the limit as x approaches 0 of the square root of 3 minus the square root of x plus 3 divided by x. Okay, so again, we have a problem in the denominator. As x approaches 0, the denominator becomes 0. And so we have to find some other way of evaluating this limit. So we have the limit as x approaches 0 of the square root of 3 minus the square root of x plus 3 all over x. And what I'm going to do is I'm going to multiply, so maybe I'll put some parentheses around this. I'm going to multiply this by the square root of 3 plus the square root of x plus 3. Now maybe you've seen this trick before, and since I'm doing it on the numerator, I also have to do it on the denominator here. So I'm essentially just multiplying by 1 because it's the same thing here. But maybe you've seen this trick before here. Whenever you see square roots in a limit and the limit cannot be evaluated easily, then there's usually some kind of trick that you have to use that involves this kind of rationalizing of the numerator. Okay, so let's multiply this out. So this is going to be the limit as x approaches 0. And again, you should keep writing the limit out front up until you actually take the limit. So in the numerator, I have square root of 3 times square root of 3, that's 3. Then I'm going to have square root of 3 times square root of x plus 3, but then I'm also going to have square root of 3 times negative square root of x plus 3. Those are going to cancel. So that's going to go away, and then I'm going to have negative square root x plus 3 times x plus 3. That's just going to be minus x plus 3. Let's see how nice that is in the numerator. Now, I wouldn't distribute the x here. I would just leave this as x times the square root of 3 plus the square root of x plus 3. You'll see why in a second. Just save you some time. Okay. Now, this numerator here, I can simplify. This becomes just negative x on top. And again, in the bottom, x times the square root of 3 plus the square root of x plus 3. And now look, the x's cancel. So that goes away, and so I'm left with the limit as x approaches 0 of negative 1 on top. That's very nice. And then the square root of 3 plus the square root of x plus 3 in the bottom. And now I can use my limit laws. I can evaluate the limit of the numerator and the limit of the denominator separately because I don't have a problem in the denominator anymore. So if I do that, well, the top is just going to be negative 1. The bottom is going to be the square root of 3 plus the square root of 0 plus 3. And notice I didn't write limit anymore because I have evaluated the limit. And this is just going to be square root of 3 plus square root of 3. That's 2 square root of 3. And then I still have my negative 1 on top. And if you want to, you can multiply top and bottom by the square root of 3. So I would get negative square root of 3 on top. And then this will just be a 3. 3 times 2 is 6. So that's my limit. Let's take a look at the graph. So if you look at the graph, you can see that we have a hole right here when x is 0. And negative root 3 over 6, that, if you evaluate it to be a decimal number, it's about negative 0.28 something, I think. It's about here. So that makes sense. As you come in from the left, you approach that value. As you come in from the right, you approach that value. And even though the function is not defined at 0, that's okay. The limit doesn't care about what happens at 0. The limit only cares about what happens as you get close to 0.